The next set of tests is to find whether the given time series is stationary or not. So here we have a time series. Time series is a data whose positions cannot be changed. So the first data will be the first, second data will be the second. You can't just make them move as we wish because they are in increasing time. So we need to use the data as it is. So that's a time series. Then in the time series data, we can see this one maybe a sales report. So the x-axis shows the time and the y-axis is showing the sales, total sales of the shop or something. Here things we can notice is there is some pattern. So the first pattern is there is upward trend. So things are going up almost linearly. And then on this linear upward trend, we see the oscillatory behavior. So this linearly moving upward is the trend, and one which is oscillating is called the seasonality. So as long as the time series has got some trend and some seasonality, then we call that time series data as non-stationary data. So this previous example is given on the top. Then from that we have extracted the trend, which is almost linearly increasing. Then once that trend is subtracted from the total data, then we find some oscillatory behavior. And if you can extract that oscillatory behavior out, which is the seasonality, then what remains is the residual. So this residual, if you look at it, you don't find any pattern in the last one. No pattern, like there is nothing trend here and there is no seasonality here. So the residual here is a stationary time series. So why do we require to do this stationarity test? A time series are stationary if they do not have any trend or seasonal effects. So when time series is stationary, it can be easier to model. Non-stationary data produces unreliable and spurious results and leads to poor understanding and hence forecasting. So basically, the machine learning is well suited with two stationary tests, Augmented Dickey-Fuller test and Kwiatkowski-Phillips-Schmidt-Shin test. So the first one, here we test whether a given time series has a unit root, that means has a trend, or more generally is autoregressive. Autoregressive means there is some relation between current data and the past data. So if you can just look at that, that means it has got some trend. So which means that if it has got a unit root, then it has a trend, which means the data is not stationary. So observations are temporally ordered. That means they are ordered as per time. They are not just a list of items or any such thing. So they are time-based data. And here the interpretation is done. The null hypothesis says that series is non-stationary. That means unit root is present in the data. And the alternate hypothesis claims that no such unit root is present, which says that the series is stationary. And Python has a function add fuller, which tests this. And when you feed the data to this function, we get many returns apart from the p-value. So leave it. We concentrate on p-value, whether to accept or reject the null hypothesis. If p-value is less than 5%, we reject the null hypothesis and claim that the series is stationary. If p is greater than 5%, then we can't reject the null hypothesis. Therefore, we declare that the series is non-stationary. Similarly, the other test, which has got a trend stationary or not. So observations need to be temporally ordered, and interpretation says the null hypothesis says that time series is trend stationary, whereas the alternative hypothesis says that it is not trend stationary. So when this function is run, we get another p-value for that along with other details, the statistical details, lag, critical value, other things. The p-value is useful for whether accepting or rejecting the null hypothesis. If p-value is less than or equal to 5%, then the null hypothesis is rejected, which means that the time series is not trend stationary. If the p-value is greater than 5%, then we cannot reject the null hypothesis, which means that the time series is trend stationary. So that means it is stationary data. So if the p-value is greater than 5%, we declare that it is stationary. So the stationarity is proved, and we can continue using this time series. On the other side, if it is not stationary, then whatever activities we do with this temporal data is not going to provide us any accurate results, because all the activities we do, all the work we do, all the analysis we do on the temporal data assume that the data is stationary. So if it is not stationary, then the results of this analysis are not useful. Just waste. So that's about two methods which commonly used in machine learning to verify whether the time series data is stationary or not. So keep watching.